Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss polyhalogen compounds. Polyhalogen compounds. Carbon compounds containing more than one halogen atom are usually referred to as polyhalogen compounds. Many of these compounds are useful in industry and agriculture. Some polyhalogen compounds are now I am going to describe it. First, dichloromethane. First polyhalogen compound is dichloromethane, also called methylene chloride. Second, I will discuss trichloromethane, also called chloroform. Third, triiodomethane, also called iodoform. Fourth, tetrachloromethane, also called carbon tetrachloride. Freons. All these things I will discuss. Okay, one more I will discuss, that is the DDT, dichloro diphenyl trichloroethane, DDT. I will discuss one by one. First, I will discuss dichloromethane. This is the example of polyhydrogen compound. First example, dichloromethane, also called methylene chloride. Dichloromethane is widely used as a solvent, as a paint remover, as a propellant in aerosols, and as process solvent in the manufacture of drugs. Three use I told you. Dichloromethane is widely used as a solvent, as a paint remover. Second, I told, as a propellant in aerosols. And third, as a process solvent in the manufacture of drugs. It is also used as a metal cleaning and finishing solvent. Methylene chloride harms the human central nervous system. Now, negative point also you should know. Methylene chloride means dichloromethane harms the human central nervous system. Exposure to lower levels of methylene chloride in air can lead to slightly impaired hearing and vision. Means it affects eye and ear. Higher level of methylene chloride in air cause dizziness, nausea, tingling, and numbness in the fingers and toes. In humans, direct skin contact with methylene chloride causes intense burning and mild redness of the skin. Direct contact with the eyes can burn. Direct contact with eyes can burn the cornea. This I told about the dichloromethane, positive and negative points. Now, trichloromethane, also called chloroform. Chemically, chloroform is employed as a solvent for fats, alkaloids, iodine, and other substances. Again I am telling you, chemically chloroform is employed, means used as a solvent for the fats, alkaloids, iodine and other substances. The major use of chloroform today is in the production of the freon refrigerant R22 freon refrigerant. It was once used as a general anesthetic in surgery, but has been replaced by less toxic, safer anesthetics such as ether. As might be expected from its use as an anesthetic, inhaling chloroform vapors depresses the central nervous system. Now negative point I am telling you, now it is not used as a anesthetics. Now it is not used. Once it was used. Inhaling chloroform, why it is not used, I am telling you now. Inhaling chloroform vapors depresses the central nervous system. Breathing about 900 parts of chloroform per million parts of air, means 900 parts per million, for a short time can cause dizziness, fatigue and headache. This is the negative point. 900 parts per million for short time can cause dizziness, fatigue and headache. Chronic chloroform exposure may cause damage to the liver, where chloroform is metabolized to phosgene. I will tell you about this point. Chronic chloroform means when anybody is taking for long, chronic chloroform exposure may cause damage to the liver, where chloroform is metabolized to phosgene, and to kidneys, and some people develop sores when the skin is immersed in chloroform. These are the negative point. Chloroform is slowly now why it is stopped, main reason I am telling you. Nowadays chloroform is not in use as anesthetic in surgery. Main reason I am telling you. Already I told some negative point, that it affects the kidney and it develops fatigue, headache, all things I told you, and it can damage the liver also, kidney also. Then now what is actually main reason? Then main reason I am telling you, chloroform is slowly oxidized by air in the presence of light to an extremely poisonous gas. What is the name of that gas? Carbonyl chloride, COCl2, also known as phosgene gas. COCl2, it's another name. This is actually carbonyl chloride. Its other name is phosgene gas. It is deadly poisonous. Means what happens if chloroform will come in contact with the air, then slowly chloroform is slowly oxidized by air in the presence of light to an extremely poisonous gas, carbonyl chloride, also known as phosgene. It is therefore stored in a closed dark colored bottles. Where it is stored actually? It should not come in contact with the light as well as in contact with the air. It is stored in a closed, dark colored bottles, completely filled so that air is kept out. Otherwise, chloroform plus oxygen. Chloroform means CHCl3 plus oxygen O2. 2 moles of chloroform plus O2, 1 mole O2. It forms 2 moles of phosgene gas, means 2COCl2. 2COCl2 plus 2HCl. Simple reaction is there. 2CHCl3, that is the chloroform, plus O2 in presence of light. In presence of light, it forms 2COCl2 plus 2HCl, where COCl2 is deadly poisonous gas. One should be careful from chloroform. Now third compounds I am telling you, triiodomethane. Triiodomethane. Here just like a trichloromethane, in the place of chlorine, iodine will come, then it is called triiodomethane, also called iodoform. Same things, CHCl3, now Cl3 remove, and iodine will come, I3, then that is called iodoform. It was used earlier as an antiseptic. Remember, it was used earlier as an antiseptic, but the antiseptic properties are due to liberation of free iodine and not due to iodoform itself. Iodoform actually releases iodine, free iodine, I2, free iodine. Then this is very, very reactive. Then in the beginning it was used as an antiseptic, but the antiseptic properties are due to liberation of free iodine and not due to iodoform itself. Due to its objectionable smell, it has been replaced by other formulation containing iodine. Okay. It is very, means the smell is very intense. That's why nowadays it is not used. It is replaced with other formulation containing iodine. Actually, iodine cures, not the iodoform. Iodine releases I2, that actually cures. Now, next compound I am telling you, tetrachloromethane, means carbon tetrachloride, CCl4. CCl4. Now, from the methane, all H removed, replaced with 4 chloride, 4 chlorine, you can tell, CCl4. All H is removed by Cl. Okay, it is called carbon tetrachloride, CCl4. It is produced in large quantities for use in the manufacture of refrigerant and propellants for aerosol cans. It is also used as feedstock in the synthesis of chlorofluorocarbons and other chemicals. See, here all points are important. It is produced in large quantity for use in the manufacture of refrigerant or coolant, you can tell. It is used in refrigerator to produce coolness, and also as propellants for aerosols cans. Propellant, we know, fuels. Then it is used as propellants for aerosol cans. It is also used as feedstock in the synthesis of chlorofluorocarbon. Chlorofluorocarbon, CFC. In shortcut, it is called CFC. This is a very dangerous gas, chlorofluorocarbons. Actually, it will go to the slowly it will go to the upside in atmosphere, and it will stay there for long period, and it will just react with ozone layer, and it will make a hole in the ozone layer, and that is called depletion of ozone layer. And from that hole, this UV light, ultraviolet lights come to the earth, and UV light is very dangerous, highly energetic. It harms the skin of the body, and it produces skin cancer. Okay. Then now I told you that this about the carbon tetrachloride, that where it is used. Actually, it is also used to produce pharmaceutical. Actually, it is used in pharmaceutical companies also. Correct? Pharmaceutical manufacturing and general solvent use. If solvent for general solvent also it is used. It is used as a feedstock, means a starting material, you can tell. It is used there. It is also used as feedstock in the synthesis of chlorofluorocarbon and other chemicals, pharmaceutical manufacturing and general solvent use. There it is used. Until the mid 1960, it was also widely used as a cleaning fluid, both in industry. It was in the beginning, near about 1960, it was also widely used as a cleaning fluid, both in industry, as a degreasing agent, and in the home as a spot remover and as fire extinguisher. See, in home also it was used as a spot remover. Some spot is there, then this carbon tetrachloride was used as a solvent. It was removing a spot. That's why it was used as a spot remover and also as fire extinguisher. If fire is there, then it was used as fire extinguisher. There is some evidence that exposure to carbon tetrachloride causes liver cancer in humans. See, very, very negative point. There is a proof, some evidence is there that exposure to carbon tetrachloride causes liver cancer in humans. The most common effect are dizziness, DIZZINESS, dizziness. The most common effects are dizziness. Second, lightheadedness. Third, nausea. And fourth, vomiting, which can cause permanent damage to nerve cells. These are the negative point. Further, in severe cases, these effects can lead rapidly to a stupor. It is virtually, it affects very, these things is very, very effective. Negative point, these are the negative point. In severe cases, these effects can lead rapidly to a stupor, coma, unconsciousness, or death. See, finally, person can get death also. Then I told you that its effects can lead very fast to stupor, 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 coma, unconsciousness, even death or death you can tell. Exposure to CCl4 can make the heart beat irregularly or stop, means that time person can also die. Exposure to carbon tetrachloride can make the heart beat irregularly or stop. Then stop means what? Heart will stop means gone case. The chemical may irritate the eyes on contact. It affects the eye also. It makes irritation to eye. When carbon tetrachloride is released into the air, it rises to the atmosphere and depletes the ozone layer. Not only CF2Cl2 chlorofluorocarbon, this also carbon tetrachloride also, when carbon tetrachloride is released into air, it rises to the atmosphere and depletes the ozone layer. Depletion of ozone layer is believed to increase human exposure to ultraviolet rays, leading to increased skin cancer, eye disease and disorders, and possible disruption of immune system. It is so dangerous. Okay, and possible disruption of immune system. Our immune system will be affected. Then this I told you about the CCl4, carbon tetrachloride. Now I am going to tell about freon. Freon, already I told you same things are here, only name is new. Freon, CF2Cl2, its name is freon. Okay, then already I told negative point of freons. What is positive point? It is used as a refrigerant. As a means in a refrigerator, it is used as a refrigerant, means cooler. It will produce coolness. Okay, main role is of refrigerating agent only. That is a main role. It will cool the air there. The chlorofluorocarbon compounds of methane and ethane are collectively known as freon. Not only of methane, even for ethane also. In methane what will happen? I told you CF2Cl2, chlorofluorocarbon. That is, in methane 4 hydrogen is replaced. 2 hydrogen is replaced by fluorine atom and other 2 is replaced by chlorine. Then it is belong to methane. And same way, same things may happen with ethane also. Then collectively it is known as freons. The chlorofluorocarbons compounds of methane and ethane both are collectively known as freons. They are extremely stable, unreactive, non-toxic, non-corrosive and easily liquefiable gases. Remember, this freon is a gas, just like methane gas and ethane gas. It is you can say chlorofluorocarbons. It is a chlorofluorocarbons of methane and ethane and are collectively known as freons. They are extremely stable. First, you understand it is stable. Second, unreactive. Third, non-toxic. Fourth, non-corrosive. And easily liquefiable gases. Means it can be liquefied. Okay. Freon 12, we are telling freon 12 means carbon is of isotope is 12. Carbon may be 12, 13, 14. There are 3 isotopes of carbon. Then carbon 12 is common. Correct? Ordinary carbon dioxide is, in that carbon is 12. Okay, this isotopes 12 only. It is found in large quantity, others are found in very less quantity. C14 is found in green trees. In green trees, there carbon is found, that is a 14. Living trees, okay, in living trees, there carbon is found, that is a carbon C14, okay. Then here I was telling you that this chlorofluorocarbon means freon are extremely stable, unreactive, non-toxic, non-corrosive, and easily liquefiable gases, means it can be liquefied easily. Freon, that is the CCl2F2, CCl2F2, CCl2F2 means 2 chlorine is 2 hydrogen gone, in its place 2 chlorine came, and other 2 hydrogen gone, 2 fluorine came. Then in this carbon is 12, that's why it is called freon 12 CCl2F2. This freon is one of the most common freons in industrial use. Actually, in industry, this freon gas is used. Okay, it is used in industries in large scale. It is manufactured from tetrachloromethane. Okay, how it is produced? Then it is produced from tetrachloromethane, means CCl4, by Schwarz reaction. Reaction name is Schwarz, SWARTH, Schwarz reaction. In that reaction, CCl4 is used. The CCl4 is dangerous gas, already I told you. These are usually produced by aerosol propellants. These freons, I am talking about, freons are usually produced for for what purpose actually I am talking about is used. Then these are usually produced for aerosol propellants as a fuels, aerosol propellants. Second, as a refrigeration and air conditioning purposes. Why it is produced CF2Cl2? Then three things I told you. First it is produced for aerosol propellants. Second, for refrigeration, in refrigerator it is used. And third it is used in air conditioning purposes. Then it is used for air conditioning purposes. Actually, now negative point, just you listen. By 1974, total freon production in the world was 2 billion pounds annually. It was produced in large quantity, 2 billion pounds annually. Most freon, even that used in refrigeration, eventually makes its way into the atmosphere, where it diffuses unchanged into the stratosphere. In a stratosphere, freon is able to initiate radical chain reaction that can upset the natural ozone balance. Okay, means it will react with ozone layer, and it will create depletion in ozone layer. And after that, what will happen? Already told you. Then now its production was more in 1974, around 2 billion pounds. And why it was produced in so large quantity? Then that time it was used for this three purpose I told you. Most freon was used in used in refrigeration, and actually it was used, but from there, from the refrigerator, I am telling you, this makes its way into the atmosphere. Anyhow, it was leaking somewhere, it was coming to the atmosphere, where it was diffuses. It was diffusing in air, and because it is stable, it will not react, and it will reach to the stratosphere. And after that, this prion, after reaching there, prion is able to initiate radical change. O3 is there, it will break O3 bond. O all will have single electron, bond will break, it will become radical. Now ozone, which was in a molecule form, now it will be in a radical form. Then first ozone layer, it will be depression will be there, and this, due to this breaking of the bond, ozone layer is going to be depleted. Then this I have told you that about the prions, positive and negative point also. Positive point, I have told you, it is used as a aerosol propellant, second refrigeration, and third for air conditioning purpose. Okay, now its use is somewhat, I can say, restricted due to this depletion of ozone layer. Now last term I am telling you, DDT. DDT, what is the full name? DDT. Then dichloro, one D means dichloro, second D means diphenyl, and T means trichloroethane. Trichloroethane. Then here actually this is a very complicated structure. This is very complicated structure, DDT. Actually its name is, correct name is PP dash, P comma P dash, 2P you are using, P comma P dash, dichloro diphenyl trichloroethane, DDT. First structure you understand, then I will tell you its properties, means negative point and positive point I will tell you. Actually, how will you remember? This is very complicated, but you can remember it. Easily you can remember it. And if you will respond anywhere, if you will answer this question, then your selection is 100%, because this all will do mistake. Nobody can tell. Very less who is very knowledgeable students are those who are prepared nicely. Only they can, that type of candidate student can tell correct. Okay, but I am telling you how you can remember. You can remember it. It looks very complicated, but you can remember. I am telling you. How will you remember structure? I am telling you. Then see, its name is P comma P dash diphenyl, 2D you have used, and then trichloroethane, DDT. Then how will you remember a structure? I am telling you. See, ethane structure you will not forget. C2H6, that you know. Anybody can tell, any student can tell. Ethane. C2H6 means carbon, both carbon are attached with single bond. And both carbon have 3 hydrogen. This is a simple ethane structure. CH3, and both CH3 is joined with single bond. Correct? Total 6 hydrogen is there. Both carbon 3. Then now here how will you remember easily? Then now I am telling you that first carbon, 3 hydrogen is there. 3 hydrogen is there. Now replace it with all 3 carbon with 3 chlorine. Then it became trichlorine. Correct? Trichloro you can tell. First carbon, 3 hydrogen gone, 3 Cl came. Now come to the other C. Then here 1 hydrogen will be as it is. 1 hydrogen will be as it is. Only 2 hydrogen will be replaced. Only 2 hydrogen will be replaced or will replace. Then how, with whom you will replace hydrogen? Then that is the very simple way I am telling you. That is the chlorobenzene. Chlorobenzene, you know, phenyl group, chlorobenzene, you have seen benzene ring. 1 chlorine is there, that is the chlorobenzene. Then both carbon will be replaced by chlorobenzene. Simple. Chlorobenzene. Then now why P and P dash is used? 2 P is used, 1 P, another is P dash. Why? Then here P and P dash is used because now this benzene and carbon, when H will go, then in its place benzene will come, benzene ring will come, chlorine is attached, then it will make bond with para position of chlorobenzene, means with respect to Cl. 4th carbon, that is a para position, that will make link with carbon. When hydrogen will go, then it will make bond with C, then it will make bond with para position, para carbon of benzene. That's why P term is used. P means here para. Same thing is for other chlorobenzene. 1 H will go and this chlorobenzene will come and it will join with carbon at, means benzene para position and carbon it will join. That's why 2 P terms are used. Just to differentiate 2 P para position, P and P dash is used. Then see how you can write easily the structure. Correct? 6 carbon. This 2 carbon atom, both were having 3 hydrogen. Then in 1 carbon, all 3 carbon replaced by Cl. And second carbon, 1 hydrogen will be as it is. 2 hydrogen will be replaced by 2 chlorobenzene, phenyl group. Okay. That's why name has been given PP dash dichloro, because 2 chlorine is attached. 1 phenyl, 1 benzene ring, 1 chlorine atom, and second again 1 chlorine. That's why it became diphenyl. Di means 2. Diphenyl, 2 phenyl group attached. And trichloro, you know, first carbon, trichloroethane. Then this is the structure of DDT. Easy way you can understand. Okay. Then name DDT, you always you should remember, because question is asked. Okay. And structure also you can remember, I told you. Now I will tell it's a positive point and negative point. Actually you should know, nowadays DDT is not in use. DDT is nowadays not in use. You remember. Why now I am telling you plus point and negative point of this DDT. DDT, the first chlorinated organic insecticide. Actually, it is insecticide. It kills the insect. DDT, the first chlorinated organic insecticides, was originally prepared in 1873, but it was not until 1939 that Paul Muller, a scientist is there, chemist, Paul Muller of Gigi Pharmaceuticals in Switzerland discovered the effectiveness of DDT as an insecticide. Okay, that time it was very effective. Up to 1933, people were knowing that it is a very good insecticide, very effective. After that, what this scientist observed, Paul Muller was awarded the Nobel Prize in Medicine and Physiology in 1948. 1873 it was discovered, and he got Nobel Prize in 1948. See how long. Okay, and up to 1939 it was very, very successful. It was considered as a very good insecticide. Then after that, what happened? The use of DDT increased enormously on a worldwide basis after World War II. It was used everywhere all over the world, primarily because of its effectiveness against mosquito that spreads malaria and lice that carry typhus. Now here see, in the beginning it was working very well, but what happened? It's a side effect, I am telling you. The use of DDT increased enormously on a worldwide basis after World War II. Okay, primarily because of its effectiveness against the mosquito that spreads malaria and lice that carry typhus. But what happened? It was used against this malaria and lice. But actually this malaria and lice was carrying typhus. Okay. However, actually this typhoid, typhus is related to that. Then it may be this biological term bacteria. Disease is there. It spreads the disease. Then typhus was, you should remember the term typhus. Typhus. Typhoid, that term is there. Typhus. And it is just like bacteria working against human being. However, problems related this because I told you that it was used just to stop the malaria and lice, because this malaria and lice was carrying typhus. However, problems related to extensive use of DDT began to appear in the late 1940. 1948 actually it got a Nobel Prize, but 1940 onward problem raised began to appear in the late 1940. What was the problem? Many species of insects developed resistant to DDT, and it was also discovered to have a high toxicity towards fish. This was the problem. First problem has come, many species of insect developed that was resistant to DDT. Now DDT was not able to kill that new insect. That new species developed, many species of insect developed resistant to DDT, and it was also discovered to have a high toxicity towards fish. Means when this DDT was going to the water, then in water, you know that all thing this fish will swallow. Then when they were using this DDT as a food, then fish were dying. Okay, that was the another problem, that this was discovered to have a high toxicity towards fish. Fish were dying. The chemical stability of DDT, it was very stable. The chemical stability of DDT and its fat solubility compounded the problem, means increased the problem. DDT is not metabolized very rapidly by animals. Again, another problem. DDT is not metabolized very rapidly by animals. Instead, it is deposited and stored in the fatty tissues. It will be in their body only. If ingestion continues at a steady state, DDT builds up within the animal over time, because it was stored in the tissues. Okay, then continuous you can say this accumulation was, if you go to the body of animals, then it will be not you can say metabolized very rapidly by animals. Instead, it is deposited and stored in the fatty tissues. If ingestion continues at a steady rate, DDT builds up within the animals over time. The use of DDT was banned in the United States in 1973, although it is still in use in some other parts of world. Okay. And this I have discussed about the DDT. Now this chapter finished, means haloalkane and haloarene chapter completely finished. Many question is asked from this chapter. All these things in what I discussed today, all questions are asked in general competition like UPSC and CSIR Neet exam is there, in that also. Everywhere in the general examination these questions are asked. Actually in general examination that question will be asked which is affecting the human body life. Okay, then now I finished this chapter, and next class I will start this things. Alcohol chapter is there, aldehyde, alcohol, that I will discuss. Aldehyde, acetone, correct, aldehyde and ketone. That chapter I will start next class. Thank you.